Dear students, now discuss about physical property and chemical property and uses for haloarene. Firstly, discuss about physical properties. पूर्व क्लास रे आम मेथड ऑफ प्रिपरेशन फॉर हालोआरिन आम डिस्कसन करथिले एवं मेथड ऑफ प्रिपरेशन तीनटा मेथड रे आम तैयारी करथिले जोटा कि फर्स्ट मेथड वन इज इलेक्ट्रोफिलिक सब्स्टिट्यूशन रिएक्शन, सेकंड मेथड इज सैंडमेयर रिएक्शन, थर्ड इज कमर्शियल मेथड और इट इज नोन एज रास्चेक प्रोसेस. नाउ गोस टू फिजिकल प्रॉपर्टी. First point, one is physical state. Physical state. Haloarene means that may be chlorobenzene or bromobenzene or iodobenzene or fluorobenzene or any derivative for halogen are present in colorless liquid. So generally haloarenes are present in colorless liquid form. Second point, oil solubility. Generally haloarene are insoluble in water because it cannot make a hydrogen bond with water, but it is most soluble in organic solvent like benzene, ether, chloroform, carbon tetrachloride etc. तेणु आम सीटा कहवा haloarenes are insoluble in water because it cannot make hydrogen bond with water. It cannot make hydrogen bond with water. But it is soluble with organic solvent, like benzene, ether, chloroform, carbon tetrachloride etc. Those are example for organic solvent. Second point is solubility. Now third point is boiling point. The boiling point for haloarene increases with increase in size of halogen atom. Fluorobenzene, chlorobenzene, bromobenzene and iodobenzene. Now the boiling point for iodobenzene is larger than that of bromobenzene, that of chlorobenzene, that of fluorobenzene. The boiling point for haloarene increases with increase in size of halogen atom. But in case of isomeric compound, isomeric means orthoisomer, para-isomer, meta-isomer, all have nearly same boiling point, so they cannot be separated by easily or general method. But in case of isomeric compound, the boiling point of a different isomer are closer with each other. So it cannot be separated by fractional distillation method. Suppose आम देखिए बर्तमान स्ट्रक्चर this is chlorine, this is known as ortho dichlorobenzene. ortho का आम लिखो O बोली ortho dichlorobenzene. Another isomer is Cl. Now this is meta dichlorobenzene. Another one para dichlorobenzene, that is P dichlorobenzene. आम कहीपर बर्तमान तीनटा भितर एमानकर बॉइलिंग पॉइंट आर क्लोजर विथ इच अदर, सो दे कैन नॉट बी इजीली सेपरेटेड by fractional distillation method. But if halogen will varies, then boiling point so increases with increase in size of halogen atom. तेणु आयोडीन जदि रहिबो ताले बॉइलिंग पॉइंट जतिके अधिक हबो, ब्रोमीन रहिले कमी जिवो, क्लोरीन रहिले कमी जिवो, फ्लोरीन रहिले कमी जिवो. Then fourth property will melting point. Fourth property आम जा melting point. Melting point also increases with increase in size of halogen. But in case of isomeric compound, the para isomer P isomer have higher melting point than O isomer, means ortho isomer, and M isomer. Why? Short question one. Why para isomer have a higher melting point than that of other? Because para isomer have symmetrical structure. देखिए आम स्ट्रक्चर symmetrical structure, so it will fitted into the crystal lattice. Thus high temperature most required to overcome such force of attraction. Therefore the melting point for para isomer is large. Now structure को आमे टिके जिबा. This is known as ortho isomer. This is known as ortho isomer. this is known as meta isomer, and this is known as para isomer. Now para isomer can have symmetrical structure. Symmetrical structure means तुम जेकोसी जगार आम गोटे एक्सीस लाइन टे पास कर देखा इक्वल हाफ रे रोज तेणु सिमेट्रिकल स्ट्रक्चर किंतु ऑर्थो मेटा सिमेट्रिकल स्ट्रक्चर नुह जदि सिमेट्रिकल स्ट्रक्चर इट मस्ट वेल फिटेड इनटू द क्रिस्टल लैटिस तेणु वेल फिटेड मीन्स देयर विल बी स्ट्रॉन्ग बाइंडिंग फोर्स एग्जिस्ट बिटवीन दिस मॉलिक्यूल एंड क्रिस्टल लैटिस. So high temperature must be required to overcome such force of attraction. Therefore, the melting point for para isomer is larger than that of other. So that is physical property for haloarene. Then ame jiba chemical properties. The important thing chemical properties. Chemical properties. Generally, haloarenes are chemically less reactive than that of haloalkane. Why haloarene is less reactive? The explanation can source by inertness of a halogen atom. By inertness of a halogen atom. The halogen atom present in haloarene becomes chemically inert or less reactive towards the various chemical reaction. The inertness of a halogen atom in haloarene can be explained by two concepts. One is resonance concept, second one is bond energy explanation. First one is delocalization of electron, delocalization of electron by resonance. Second one is bond energy explanation. First देखिबा सामे resonance phenomena को केमिति शो करूची halogen atom present in haloarene is less reactive. The resonating structure for chlorobenzene shown as भल भाव देखिए रिजोनेटिंग स्ट्रक्चर कहीं आमको सबुआड़े से रिजोनेंस फेनोमेना आमको दरकार. Now it containing 3 pi bond and 3 lone pair of electron around chlorine. बर्तमान आम कौन करवा सपोज गोटे पेयर ऑफ इलेक्ट्रॉन को ए कार्बन क्लोरीन बिटवीन को आम प्लेसमेंट दबा. नाउ दिस कार्बन बिकम्स पेंटावेलेंट 1 2 3 4 and new bond will form, that is 5. Automatically pi bond becomes delocalized. pi bond टा रिमूव हो ताले आमे पाइबा रिजोनेटिंग स्ट्रक्चर. गोटे रिजोनेटिंग स्ट्रक्चर को आमे सोचेबा by help of double head arrow sign देखी. तेणु आम लिखिपर डबल बॉन्ड Cl chlorine pair of electron, this becomes plus and this carbon becomes minus with a pair of electron. Now the old double bond remains as such. When this pair of electron moves in between the carbon, again this carbon becomes further pentavalent. Now 2 bond to 4 and 1 hydrogen remains present at that position. So automatically this pi bond can delocalize to the next carbon. Now draw the resonating structure. Double bond Cl plus contain 2 pair of electron. Now make new bond, old bond present. Now this carbon becomes negative with a pair of electron. When this pair of electron moves in between these 2 carbon atoms, automatically the pi bond becomes delocalized due to pentavalent for carbon. ताले आमे कोनटा लिखि परिबा डबल बॉन्ड Cl प्लस पेयर ऑफ इलेक्ट्रॉन डबल बॉन्ड माइनस विथ पेयर ऑफ इलेक्ट्रॉन. फर्दर पुणी आमे पेयर ऑफ इलेक्ट्रॉन दबा दला पर नाउ दिस कार्बन इज मेक पेंटावैलेंट एंड रिमूव दैट पेयर ऑफ इलेक्ट्रॉन. Double bond. Now chlorine, pair of electron. Now 1, 2, 3, 4, 5 are the resonating structure for chlorobenzene. Now the resonance phenomena will indicates halogen becomes highly electronegative element, but it containing a positive charge on it. So the nucleophile cannot easily replaced. And also another situation arises. Now the resonance phenomena will indicates ortho and para position are electronically rich. So the electrophile must attack at ortho and para position. Therefore aromatic compound can easily show electrophilic substitution reaction at a faster rate than that of a nucleophilic substitution reaction. Now halogen is said to be ortho para director but deactivator. हालोजेन जो हमको रोचे क्लोरोबेंजीन मन रखिबो दैट इज ऑर्थो पारा डायरेक्टर बट डीएक्टिवेटर. व्हाई इट कैन से डीएक्टिवेटर? बिकॉज द हालोजेन एटम सो प्रेजेंट इज ए हाईली इलेक्ट्रोनेगेटिव एटम बट अकॉर्डिंग टू माइनस आई इफेक्ट हालोजेन इज ऑलवेज माइनस आई एटम. According to minus I effect, it can withdraw some certain amount of electron from ortho and para position. Therefore, electrophile must attack at a slow rate. So it is called deactivating. ठीक है, सेट जानी नबो. Halogens are ortho para director. Ortho para director कहीं की नामको resonance phenomena indicates ortho and para position are electronically rich, so the electrophile must attack at ortho and para position. Halogens are ortho para director but deactivator, means the reaction rate becomes slow due to presence of minus I nature for halogen. आमे बर्तन जीवा से ठीक हमर मुख्य जिनिस अछि इनर्टनेस. Now the resonating structure shows the halogen atom attached to the carbon atom in benzene ring with help of a double bond. When it should make a double bond in between them, then such atom becomes closer to the carbon nucleus. When closer to the carbon nucleus, then bond becomes shorter and it is stronger in nature. Therefore, it cannot easily replaced. So, the halogen atom in haloarene is chemically inert. Second is bond energy explanation. आम कंपेरिजन बर्तमान करिपरिबा one is haloarene, another is alkyl halide. Suppose this is chlorobenzene, another one are CH2X or Cl. This is haloarene, that is alkyl halide. In case of, in between them, haloarene are less reactive than that of alkyl halide. Why? Now the halogen atom attached to the carbon atom becomes sp2 hybridized, but the halogen atom attached to the carbon atom in alkyl halide is sp3 hybridized. The sp2 hybridization indicates the percentage of S character becomes 33.3%. But in case of sp3, the percentage of S character is 25%. You can know greater is the percentage of S character, more is the electronegativity. जदि S रो परसेंटेज कैरेक्टरटा अधिका हुए ताले आम कहि परिबा इलेक्ट्रोनेगेटिविटी तार अधिक. तेणु दिस कार्बन एंड दिस कार्बन, द परसेंटेज ऑफ S character becomes large for this carbon. Now you can suggest this carbon becomes much more electronically negativity than that of this carbon. If it will be more electronegativity, then it automatically attract the electron from carbon chlorine bond. So the bond length becomes decreases and it is known as 164 pm means picometer. But in case of the carbon halogen bond becomes bond length will 177 pm. Due to high electronegativity nature, it can attract the chlorine towards the carbon nucleus and the bond length becomes decreases. The decrease in bond length can show increase in stability. The stability increase can indicates it cannot easily replaced, and both concept will suggest the halogen atom so present in haloarene is chemically inert or less reactive under normal condition, but on vigorous condition it can show certain number of chemical properties. Second is nucleophilic substitution reaction. B. Nucleophilic substitution reaction. Under normal condition, chlorobenzene or haloarene do not show nucleophilic substitution reaction. But under drastic condition or vigorous condition, it can show some specific number of nucleophilic substitution reaction. First reaction with aqueous sodium hydroxide or aqueous alkali. When chlorobenzene on reacts with aqueous sodium hydroxide at about 630 Kelvin temperature under 200 atmospheric pressure to form sodium phenoxide which on acidification with dilute hydrochloric acid to form phenol. This is the one method of preparation for phenol. Such process is known as dose process. Remember, ताले हमें कौन कहिल सेटा इक्वेशन आकार में देखिबा when chlorobenzene, now this is chlorobenzene on reacts with sodium hydroxide aqueous means you know that must be dissolved with water. Condition will 630 Kelvin temperature, 200 atmospheric pressure. Then it will form Cl, H will be removed, that is HCl, to form ONA plus HCl. Now this compound is known as sodium phenoxide, O minus Na plus. When it reacts with dilute hydrochloric acid, then it will form phenol, means OH and remove NaCl. This compound is known as phenol. Such process can proposed by scientist dose, so it is named as dose process. In this reaction, the nucleophile can Cl minus remove, and at last situation it will observe OH can enter. But this reaction occur at a slow rate than that of alkyl halide. First reaction. Second reaction is reaction with ammonia. Second nucleophilic substitution, reaction with ammonia. Reaction with ammonia. Ammonia formula, no, NH3. When chlorobenzene on reacts with ammonia, in presence of cuprous oxide, at about 473 Kelvin under 60 atmospheric pressure, to form aniline to form aniline. Equation. This is chlorobenzene. When reacts with ammonia formula is NH3. Now you can take 2 mole of ammonia with cuprous oxide, that is CO2O. Condition is 473 Kelvin, 60 atmospheric pressure. This is known as chlorobenzene. Now form aniline. This is also 2 mole. Aniline plus 2CuCl plus water. This is known as aniline. How it will form? Now NH3 can be ionized to form H plus NH2 minus. Now Cl and H can be removed in first molecule. Similarly, in case of second molecule, HCl can be removed and NH2 is substituted. It can produce 2 mole of aniline. Now 2HCl will combine with cuprous oxide to form cuprous chloride and water. This is the second nucleophilic substitution reaction for haloarene. Third reaction is reaction with cuprous cyanide. Cuprous cyanide means CuCN. When chlorobenzene reacts with cuprous cyanide. Now the nucleophile will is Cn minus cuprous cyanide in presence of pyridine to form cyanobenzene or phenyl cyanide. Now this is chlorobenzene. Cuprous cyanide plus CuCN. Cu plus Cn minus. The reaction occur in presence of base catalyzed, that is pyridine, heat condition. Now Cn minus attack to the position, chlorine will act as a leaving group and to form cyanobenzene, or it is called phenyl cyanide. Cn plus CuCl. This is known as cyanobenzene, or it is other name is said to be phenyl cyanide. Now the 3 type nucleophilic substitution. First one is aqueous sodium hydroxide, second one is ammonia, third one is cuprous cyanide. Thank you.